All right, today we're going to talk about something that is quite literally the foundation of our world, concrete. You see it everywhere. But the story of this gray stuff is way more fascinating than you might think. So, just to give you an idea of the sheer scale we're dealing with, let me ask you a quick question. If you take water out of the equation, what do you think is the most used substance on the entire planet? Yep, it's concrete. I mean, think about it. The sidewalks you walk on, the tallest skyscrapers, the massive dams holding back rivers, our entire world is built with it. It's the silent, solid partner in pretty much everything we do. So, if we're going to understand why it's so important, we have to start with the basics. What exactly is this stuff that we use by the billions of tons every single year? Well, you might be surprised to hear that concrete is mostly just filler. Seriously, about 3/4 of it is what we call aggregate, which is just a mix of sand and gravel. The real magic is in that other 25%, this paste that acts like a super strong glue holding all those rocks together. The easiest way to think about it is like you're baking a cake. First, you mix your wet ingredients, that's the cement and water, to make the paste. That's kind of like your batter. Then you mix in the sand, and now you've got mortar. And for the final step, you fold in the gravel to get the finished product, concrete. It's really just a simple step-by-step recipe. Now, making that recipe on an industrial scale is a whole other beast. It follows this really specific process. It all starts with measuring the ingredients, which is called batching. Then you mix it, transport it, and place it. After that, you've got consolidating, finishing, and curing. For now, we're going to focus on those crucial first few steps, because that's where the quality is really decided. But before we even get to the heavy machinery, we've got to talk about the science. Because inside that simple mix, there's a secret. There's one key ratio that determines whether you get incredibly strong concrete or just a crumbly mess. And that secret ingredient, it's just water. But water has two very important and kind of conflicting jobs to do. First, it's the catalyst. It kicks off the chemical reaction, called hydration, that makes the cement get hard. But second, it's what makes the mix workable. It gives it plasticity, so you can actually pour it into a mold. And this brings us to the golden rule of concrete. It is the absolute number one most important thing to remember. The more water you add compared to the cement, the weaker your final product is going to be. Period. And here's why that rule is so critical. See, a mix with just the right amount of water creates a really dense, really strong material. But if you add too much water, yeah, it's easier to pour, but all that extra water eventually has to go somewhere. It evaporates, and when it leaves behind a network of tiny little pores and channels that basically turn your solid concrete into a weak sponge. So this creates the central challenge, right? It's a classic tug of war. The engineer designing the building wants maximum strength, which means using as little water as possible. But the construction crew on the job site needs a mix that's fluid enough to actually work with. So how do you make both of them happy? Well, the answer lies in being incredibly precise and using some serious industrial power. Let's take a look at how this perfect recipe is brought to life, ton by ton, starting with how the ingredients are measured out. That first step is called batching. It's basically just a fancy word for measuring out the exact proportions for every single batch of concrete. And when you want a consistent, high-quality mix, you absolutely want to measure by weight. It's just way more accurate and dependable than trying to measure by volume. So, all the solid stuff, the cement and the aggregates, your sand and gravel, that's all measured by weight to get it just right. The liquids, though, like the water and any special chemical additives, are usually measured by volume. And for big projects, this is what that looks like. We're not talking about guys slinging bags of cement around, no way. The cement arrives in bulk and gets stored in these enormous silos, ready to be weighed out with incredible precision for every single truckload. Once everything's been measured, it all gets dumped into a massive mixer. To make sure you get a perfectly uniform mix, you've got to let it churn for at least a full minute, even for a small batch. That gives the cement paste enough time to coat every single piece of sand and gravel. For bigger batches, that mixing time gets even longer. Okay, and now we get to the action. Because as soon as that concrete is mixed, a clock starts ticking. It is a full-on race against time to get that fresh, wet concrete from the plant to its final resting place. When you're moving fresh concrete, you're juggling three big goals. You have to do it as cheaply as possible, you have to keep the heavy gravel from sinking to the bottom, and most importantly, you have to get it in place before that chemical hardening reaction really kicks in. And the method they use totally depends on the job.
I mean, it could be as simple as a hand buggy on a small site, or as wild as a crane hoisting giant buckets of it, or even powerful pumps pushing it through pipelines hundreds of feet into the air.
But it doesn't matter what method you use, the goal is always the same. Get the concrete poured before it hits what's called an initial set. That's the point of no return where it starts to lose its plasticity and begins to harden for good. Once that happens, the race is over and you've lost.
So there you have it. From a simple recipe of rock, sand, cement, and water, we get the material that literally builds our civilization. It's an ancient technology that has become the foundation of our modern world. Which kind of leaves us with one big question to think about. What does the future hold for this essential but pretty carbon-intensive recipe?